Okay, so we're looking at the addition rule and a little bit of conditional probability here. Start with question A. We're after the probability of B, and easy enough because we know the probability of not B. Probability is total 1 minus probability of not being gives us the probability of being B. Part A, easy enough. Part B, slightly more awkward. What we've got, and a nice way to think of this is in terms of these Venn diagrams. And what we do know is that the probability of A or B, the total of these two things, is 7/8. And so probability of A or B we know is 7/8. Now we can get that alternatively by adding the two probabilities of A and B together. So total of A and B gives us the total of A or B together. The trouble is if we add A and B, what we do is we end up adding this intersection twice, which means we need to take it off once. So if we take off that intersection, which we would have counted twice, then we get the total. Probability of A, we know. Probability of B, we've just figured out. And the only bit that we don't know is the bit we're after. Add these together, and let's add them. Get 20ths, 8, 15, 23 20ths. 7/8. Subtract as 40ths, and that will give us 11 40ths as our intersection there. Part C, this is a conditional probability. Probability of A given that B has occurred. Thinking of the Venn diagram again, the probability of A, given that B has occurred, means that we're in B, we assume B has happened, and we're after the probability of A. That's to say this section here. So the A's, given that B has happened, is this overlap, which we've just figured out of B, which we know. That's our conditional probability statement. Probability of A intersection B, we know. Probability of B, we know. And let's make that 11 40ths, 30 40ths, and cancel the 40s, 11 30ths. There's my answer.